All right, so today we're going to go over 6.2, and the goal is to recognize parallel and perpendicular lines in a coordinate plane. And then you'll be able to answer the question, how can I determine if two lines in a coordinate plane are parallel or perpendicular? Is visual examination, that is, it looks like it, is that sufficient enough? And so you already know what parallel and perpendicular lines are. You see them all around you. In fact, if you're looking at my screen right now, you can notice that there are some perpendicular lines here along this page right here. These are perpendicular. And then these two lanes right here are parallel, this one and then this one. So you're seeing all kinds of parallel lines. In fact, if you look at these words and then this line here, you can consider those as parallel. Okay, so we need to come up with a way to be able to tell if two lines are parallel beyond just it looks like it. Okay. So in Leaping Lizards, you probably thought a lot about parallel and perpendicular lines, particularly when you translated the anchor points of the lizard the same distance in the same direction, or rotated the lizard about a given center through a 90-degree angle, or reflected the lizard across a line. It would be helpful to be able to predict when the lines in a coordinate grid are parallel or perpendicular to each other. So examine the following diagram and write statements to describe which statements are parallel to each other. So go ahead and take a second and look at which lines are parallel. And just a reminder, if you're going to say this line right here, you label him. You can kind of talk about him by 2 points that are located on that line. So you can say line EF, and you would write EF, line EF, like this, EF. And then that means segment if his hat looks like that. And if I put 2 little arrows on each, one arrowhead on each side, then that means it's a line, meaning it goes on forever. And some of you are thinking, Ms. Johnson, it's not going on forever. It stops right there. But one of the things you can know is that if I cut a picture off and you see the frame, can you see how this is like the frame of the picture, right? If it goes to the frame of the picture, you can assume whatever it's doing outside the frame, it continues that pattern, right? So you can say EF is parallel to what? So I want you to take some time right now to figure out which lines here are parallel. Which lines here are parallel? And write a couple of them. Write the ones that you know. Okay. And hope, I don't know, maybe you said that EF is parallel to DG, maybe. I don't know, maybe you said that. And maybe you said they are also parallel to BO. Maybe. I don't know, maybe you said that AB is parallel to IH. I don't know if you said that. So how do you know if two lines are parallel? Okay, so I'm not sure which ones you said. Maybe you even said these two were parallel here. Oops, I can't even draw. Sorry. Let's try that again. Oops. Okay. Maybe you even said these ones were parallel. I'm not sure. I don't know which ones you said were parallel, but today we're going to figure out which ones are based on our kind of exploration. So how did you know that these lines were parallel other than they look like it? Was there something that you could figure out? Was there something that you can calculate? All right. So it says you may have written your statements about parallel lines using such words as the line through points A and B is parallel to line through HG. And we can state the same idea symbolically. So here symbolically, you can say AB, and they said line, so I put a little arrowhead there, is parallel to, so I go like this. I put 2 little lines parallel through the points through the line HG. Okay, so just a couple of things. When you're typing this on Desmos, you so for the line, you'd have to copy and paste that because there's some, it's latex. There's some code that you'd have to write. So don't worry about that. Just put in front of it line AB, write out the word line AB. But those parallel symbols, if you look and you hit shift and then there's a key between backspace and enter, and there's a straight vertical line. That is that symbol. You just hit it twice. Okay. So now that we have made an observation about the slopes of parallel lines, so it will always be helpful to make an observation about the slopes of perpendicular lines. So maybe one of the things that you noticed about these two yellow lines here is that they have the same slope. So let's look at that really quick. Let's look at HG and count that. So HG goes up 4, and then it goes right that many. What is that? 4 plus 5 plus 3? 12. So the slope of HG is 4 over 12, or 1/3. And then the slope of B, of AB, was it AB? Yeah, of AB from A to B is 1/3. So it's 1/3. So the slope of this is 1/3. So notice how your slopes, your slopes are the same. Okay. We just made an observation, right? So now it'd be good to look at the perpendicular line. So perhaps in Leaping Lizard, you considered a protractor or some other tool to help you make a right angle. In this task, we're considering to create a right angle by attending to slopes of the coordinate grid. We begin by stating a fundamental idea for our work. Horizontal and vertical lines are perpendicular. For example, on a coordinate grid, y equals to 2, this is y equals to 2 right here, is perpendicular to the line x is equal to 3. And they form right angles. And so if you remember from, I don't know, maybe it was fourth, I don't know, whenever they taught you that this little square in the vertex means that this means it's a right angle. Okay. Which means that the measurement is 90 degrees. Okay, so just kind of keep that in mind. But what if a line or segment is not horizontal or vertical? How do we determine the slope of a line or line segment that will be perpendicular to it? So we're going to do some experiments. We're going to play with it and see if you guys can come up with it. Whenever you come up with an idea and you test that idea, it's so much more powerful. But like keep that in mind. Okay. So here we go. It's 2, 3 and 4, 7. 2, 3. So consider the points 2, 3 and 4, 7, and the line segment AB between them. What is the slope of this line? Okay, so first they just want to know the slope. So that's something that you guys can do. So go ahead and figure out the slope of this line. Okay, and hopefully you figured it out like this. And you went on the elevator and you went up 4 and you went right 2. So the slope here is going to be 4 over 2, which is just 2. And I'm going to put it over 1 just so that it's obvious for you guys. Okay, so here the slope is 2 over 1. It says locate and name a third point C, which you have to find, on the coordinate grid so that the points A, which is 2, 3, and B, which is 4, 7, and C, which is x, y, form the vertices of a right triangle where AB is the hypotenuse. So they just want you to find the point C where this is now a right triangle. And if you look, this is already a right triangle. and this is the hypotenuse. So you can use this as your point C if you like, but that's not the only one. Can you find the other point that would make that a right triangle? Can you find the other point that would make that a right triangle, right? Very good. Some of you said here. Very good. So I'm just going to leave the point as I have it up there because then that's just going to be easier. So that's the point 2, 7. So C is 2, 7. Okay. So explain how you know that the right triangle you formed is a right angle. Well, how do you know that this is a right triangle? How do you know that this is a right triangle? Okay, and so some of you said, well, earlier you said, Ms. Johnson, that horizontal and vertical lines are perpendicular. So that means that this is a right angle in here. So therefore it's a right triangle. Very good. All right, let's do our next. It says now rotate this right angle 90 degrees about the vertex of point A, which is 2, 3. Now they want you to rotate this triangle about point A. So can you imagine you rotating it? So here we go. We're going to rotate it around point A. Ouch. So you're going to rotate this 90 degrees, something like this, right? So that B rotates, C rotates, and then you have this whole new triangle. Okay. But now it's 90 degrees. Can you guys all come up with that? So if you think about it, this segment here is now going to go this way, right? So this C is now here. So we'll call him C prime. So you see how that switched over? So now it's here. So let's see, this guy moved all the way over here. So do you see how that's 90 degrees? And same with this guy now. This guy here, this green guy here, is now going to rotate 90 degrees. But where is he going to end up? Well, if you think about this right triangle, this guy's going to follow. Since this is 2 this way, now it's going to go 2 this way. Wait, let me erase some of this stuff because it's too messy. Hold on, sorry. So now it's going to go 2 this way. Do you see how your right triangle is right there? And then here's your hypotenuse. So this is B prime. And then this is that one thing right there. So that's how I rotated it. I rotated the one that was easiest first, which was the segment CA. And then I rotated it so that now it's there. So this is now 90 degrees. This is the first one that I rotated. So now it's 90 degrees. Okay. Then part E says, explain how you know that you've rotated 90 degrees, because I went, let's see, how do you know that we rotated this 90 degrees? Yeah, some of you are saying, well, Ms. Johnson, if we take this segment here, AC, and we want it to be rotated 90 degrees, perpendicular to a vertical line will always be a horizontal line. Right? So there's your horizontal lines. Okay. That's how you know. And then it says, compare the slope of the hypotenuse of this rotated right triangle with the slope of the hypotenuse of the pre-image. Okay, so now they want you to compare the slopes of AB versus AB prime. Okay, so this is AB. So now we want to find AB prime and find his slope. So let me go AB prime. So what is M equal to in this case? So now find the slope of AB prime. Can you do that? Some of you are like, okay, well, Miss Johnson, to go from A, you go -4 and you go up 2. So the rise is 2 and the run is -4, which when I simplify it, that's -1/2. And then they wanted you to compare these. So does anybody see anything neat, significant? I always play the game like, how did we get from here to here? How do you get from here to here? And some of you are already seeing that pattern. So write your pattern down here. Write your pattern. What pattern did you see? So here's slope of AB. Is 2/1. And the slope of AB prime is -1/2. Okay. All right, let's move on. So consider the points A, 2, 3, and 5, 4. And the line segment. What is the slope of that segment? So go ahead and find that. So I always go from lower point to higher point. And so this is 1/3. So this is M equals to 1/3. Locate and name a third point on the coordinate grid so that it's a right triangle, which we just did that. That's how we found our slope. So what is that? 4, 2, 4. Now again, you can use this other point. It doesn't really matter. Explain how you know that's a right triangle, which you did. Now rotate this 90 degrees around 2, 3, and explain how you know that you have a right rotated the 90-degree angle. Okay, so now I want you to do this one. Now the way we started was we took this line here and we rotate it this way. So go ahead and do that and find your triangle. Okay, so I did, and I got this to be here. And then, sorry, that's supposed to be C. Okay, so here is now, oops. So now this is C prime, right? And then notice how here it goes to the right 3, right? So then I'm just going to go up 3 from that. And now do you see your right triangle? Do you see how it's rotated 90 degrees? And here's your B prime. They're going to ask you to do the same thing. Explain how you know that it's a right triangle. We talked about this. And now rotate it. Explain how you know that you rotated it. And then last but not least, compare your slopes. So find your slope of AB prime. So AB's slope we said was 1/3. What's AB prime's slope? What did you get? So what I got was -1. I went left 1 and then up 3. Right? So my slope is always going to be rise over run. So that's 3 over -1. And then I ask you to again compare. How did you get from here to here? Is that the same rule that you use to get from here to here? Because if you did, then you found a pattern. And you want to test that pattern, right? All right. So I'm going to have you do this one. It's experiment 3. It's the same thing. You guys are going to test it on your own. You're going to compare your slopes. Experiment 4, I still want you to do the same thing, and you're going to test it. And then, so based on those observations, tell me about the slopes of those perpendicular lines. While this observation is only based on a couple examples, can you create an argument or justify a justification of why you think that's always going to be true? Okay. Just for symbolic sake, because I don't think I showed you this yet. So if I'm saying that two lines are perpendicular, so for example, a lot of them were AB and AB prime. If I'm saying that these two lines are perpendicular, we use this symbol. It looks like an upside down T, right? Okay. So give me 1 second. I'm going to go over the takeaways. Okay, so in terms of takeaways, I wanted to go over here. Today you were supposed to learn how to tell if lines were parallel and lines were perpendicular. So go ahead and fill that statement in. We also talked about opposite reciprocal slopes. And actually, we didn't talk about this, but that's how you know if the lines are perpendicular, if they're opposite reciprocals. An opposite means, just so that we're on the same page, when we were talking about slopes, right? These slopes here were opposite reciprocals. Opposite because one was positive, one was negative. And reciprocals because the numerator became the denominator and the denominator became the numerator, right? And then another way to view these two is, according to this, is if the slopes, when you multiply them, so if I multiplied 1/3 times negative or 3 over -1, their product is -1, okay? Okay. Parallel lines have the same slope, which we saw. Remember, the two lines had 1/3 and 1/3. And then perpendicular lines or line segments are perpendicular if they have opposite reciprocal slopes, or if one is vertical and the other one's horizontal. Two lines are perpendicular if their intersections form 4 right angles. Remember, and we showed you that little square at the corner means a right angle. Okay, so now you know all of the things. Make sure that you're comfortable with all that. Have a great day.